Hey everyone, welcome back to FAB plus app. Have you ever noticed your phone getting, really hot, maybe when you're gaming hard or recording one of those long 4K videos? It's a thing, right? As these flagship phones get more and more powerful, dealing with heat becomes, well, a serious issue. So today we're going to explore the cool secrets, literally, behind the iPhone 17. We want to figure out how Apple manages to cram so many powerful chips into such a slim design and, crucially, still keep it from overheating. Okay, let's peel back the layers then. Let's start with the basic problem. Before we jump into the iPhone 17, why do our phones get warm, sometimes hot, in the first place? What's actually going on inside?
Right. Well, what's fascinating, and maybe not surprising, is that the main source of heat is really those internal chips just working flat out. Think about the CPU, the graphics processor, GPU, the AI engine, which is doing more and more, and even the 5G modem, pulling down data. They're all tiny powerhouses. When you fire up something demanding, could be editing photos, a long video call, or maybe you're deep into a game like, say, Aetherborn Chronicles, those components are basically sprinting. And like any engine running at full tilt, that generates heat. A fair bit of it, actually.
Okay, so it's not just being on, it's the actual intensity of the work they're doing, pushing data, making calculations. And if that heat isn't dealt with properly, what happens then? Besides just feeling warm in your hand, what are the immediate effects for you, the user?
Oh, it's more than just discomfort. If that heat builds up and isn't dissipated effectively, the phone's performance starts to suffer quickly. You'll see slowdowns. It's like asking someone to run flat out in really hot weather. They'll tire, slow down, eventually struggle. For your phone, this means, noticeable lag, apps might crash, games get choppy frame rates. The whole thing just feels sluggish. But it's not just about that immediate performance hit. Maybe even more importantly, sustained high temperatures can actually shorten the lifespan of the components inside, especially the battery. So, yeah, effective thermal management is kind of this hidden, unsung hero in modern smartphones. It's absolutely vital for performance and for making sure your expensive device lasts.
That really clarifies why this is such a huge engineering puzzle. And speaking of puzzles, this is where it gets really interesting with Apple, right? They're famous for sleek, thin designs, but keep packing in faster silicon. Our research, looking at industry analysis, teardowns, all that, it points to some pretty significant changes inside the iPhone 17, specifically for heat. What did you find were the standout internal shifts?
Yeah, it looks like a real rethink of the internal architecture. Specifically for the iPhone 17, we're seeing about 4 major modifications, all geared towards handling the heat from that new A19 Pro chip and, importantly, the new AI modules, which can be power hogs. First up is the stacked logic board. Now, this isn't just rearranging things side by side. It's literally stacking chips and circuits vertically. Imagine
Ah,
building like a tiny electronic high-rise inside the phone.
whoa.
Yeah, and the key benefit is it dramatically shortens the distance heat needs to travel to get away from the source, makes the whole heat transfer process way more efficient.
So shorter paths mean faster heat escape. That's clever. But stacking, that sounds incredibly complex to manufacture and something so thin. What's the big challenge there? Does it create new problems?
Oh, it's immensely complex. The precision needed is mind-boggling, getting those layers connected perfectly, ensuring signals don't interfere, and making sure heat can actually move between the layers effectively. But Apple seems to have cracked it. It's not just shorter paths, it's like they've designed a mini thermal highway system inside, guiding the heat exactly where they want it to go. Very deliberate thermal mapping.
Okay, thermal highways. Got it. What else?
Second, there's been a really important battery layout optimization. Sounds simple, maybe, but how and where the battery sits, even slight changes to its shape, has freed up crucial internal volume. And that extra space, even if it seems small, is vital for better airflow inside and just generally better cooling, creating little channels and pockets for air to move or for heat to spread.
Right, so it's not just the hot components, it's giving everything space to breathe, optimizing the whole internal layout.
It's exactly right. Third, they're using new thermal adhesives and materials. We're not talking about basic glue here. These are specialized compounds, maybe polymers filled with conductive particles, designed specifically to boost heat conductivity. Think of them like thermal grease but more advanced, helping to pull heat away from, say, the processor and spread it towards the frame.
Like thermal conduits.
Precisely. And finally, number 4 is subtle but important. Frame adjustments. The actual metal chassis, aluminum or titanium, isn't just for looks or strength. It's been tweaked to help spread heat more evenly across the entire outer surface of the phone. So the frame itself becomes part of the cooling system, radiating heat away.
Wow. So the case itself is a heatsink.
Effectively, yes.
Right.
It actively
Yeah.
participates in conduction. So you add all these upstacked board, battery placement, better thermal material, smarter frame, and you get a system much better prepared for that A19 Pro heat.
It's just amazing how much engineering is hidden away in there. Okay, so we've seen how they've rearranged the internals, but what about the actual tech doing the cooling work passively? What specific materials or methods are pulling the heat away inside the iPhone 17?
Right. Apple relies heavily on a mix of passive solutions. No fans here. One key player is graphite sheets. These are super thin sheets, often placed strategically, maybe between the logic board and the battery. Graphite is great at conducting heat laterally, so it pulls heat away from hot spots quickly and spreads it out.
Like a thermal wick, sort of drawing the heat sideways.
That's a good way to think about it, yeah.
Yeah.
Then you've got aerogel insulation. This stuff is incredible, super light, often called frozen smoke, and a fantastic insulator. Apple seems to use it to shield sensitive components like camera sensors or maybe the memory chips from the heat generated by the main processor. It stops the heat bleeding over and causing issues.
Protecting the neighbors from the noisy, hot component next door.
Exactly, protecting the delicate bits. Then we also see copper heat spreaders. These are usually very thin copper layers placed right on top of, or very close to, the main system on chip, the SoC. Copper is another excellent conductor. Its job is to take that really concentrated heat from the tiny chip surface and spread it out over a larger area very quickly. Prevents those intense local hotspots that cause throttling.
Diffusing the heat, basically.
Diffusing it so other parts can handle it better.
And you mentioned the frame earlier acting as a heat sink. How does that connect with these internal bits?
That's the chassis-assisted cooling element. It's the final destination for a lot of that heat. The graphite, the copper spreaders, the overall layout, they're all designed to efficiently transfer heat to the metal frame. The frame then acts like one large external radiator, conducting the heat to the outside air, your hand. That warmth you feel when the phone's working hard, that's actually the cooling system doing its job successfully, moving heat out.
Okay.
So yeah, even without a fan, this combination of smart material choices and clever design achieves really impressive thermal performance.
It really is a complex dance of materials and layout. Which brings up the obvious question, the one people always ask. If it's so complicated to do passively, why doesn't Apple just put a tiny fan in there, like you see in gaming laptops, or even some specialized Android phones? Seems easier, no.
That's a fair question, and it really boils down to Apple's core design philosophy. What do they absolutely prioritize in an iPhone? Think about it. Complete silence is huge for them. Water and dust resistance is non-negotiable. That sleek, seamless, thin design aesthetic is paramount. And deep integration between hardware and software. A fan. That introduces noise, even a tiny one. It creates openings bad for water resistance. It adds physical bulk and complexity, messing with that slim profile. It's just counter to everything they aim for in the iPhone's physical design.
Yeah, I can see that. Making a tiny, silent, waterproof fan sounds like an absolute nightmare. And honestly, I like my phone being quiet.
Right, so instead of active cooling like a fan, they double down on this sophisticated system-level approach, tackling heat from multiple angles. A big part is designing the chips themselves to be more efficient from the start, reducing power consumption at the silicon level. That A19 Pro, for example, built on a 2-nanometer process. Smaller transistors generally leak less power, run cooler for the same performance, so less heat generated in the first place. That's step one.
Prevent the fire rather than just fighting it.
Exactly. Then there's smart task management within iOS. The operating system is clever about distributing work. Less demanding tasks get pushed to lower power, high efficiency cores whenever possible. You don't use your most powerful engine core just to check the time, right? This spreads the load, avoids maxing out the hot cores constantly. And finally, the whole system is temperature aware. It's constantly monitoring temps across different components. If things start getting too warm, it can dynamically adjust performance, maybe slightly lower the chip's clock speed, dim the screen a bit, manage background tasks, often so subtly you don't even notice. But it keeps things within safe thermal limits.
So it's throttling, but in a much smarter, more granular way.
You could call it intelligent throttling, yes.
Yeah.
It's this whole integrated strategy, efficient chips, smart software, dynamic adjustments that's really Apple's secret sauce for cooling. Proactive and responsive, not just brute force.
That makes so much sense. It's not one thing, it's everything working together. And it makes you appreciate when your phone doesn't feel like a hot potato after using it hard. So looking forward then, as chips inevitably get even faster, more AI crammed in, what's next for phone cooling? What kind of innovations are on the horizon to keep these pocket rockets from melting?
Yeah, cooling is definitely going to remain a huge challenge. Probably the challenge for enabling future performance gains, especially with on-device AI booming. We're already seeing some interesting tech emerge, things that might become more common, like microvapor chambers. Some Android phones use these already. They're like tiny, flat heat pipes inside the phone. They use a liquid that vaporizes when it gets hot, moves quickly to a cooler area, condenses back to liquid releasing the heat, and flows back. It's a continuous cycle. Very efficient heat transfer.
Wow, like a tiny passive refrigerator cycle.
Sort of, yeah, on a miniature scale.
Yeah.
We might also see more phase change materials, or PCMs. These are materials that absorb a lot of heat when they melt and release it when they solidify. They can act like a thermal battery, soaking up heat during intense bursts and releasing it slowly later. Smooths out the temperature spikes.
Interesting, like a thermal buffer.
Exactly. And you mentioned AI. Well, AI-based cooling control is another big one.
Hmm.
Imagine the phone learning your usage patterns and predicting when it's likely to get hot. Then it could proactively adjust things, maybe tweak screen refresh rate, manage core usage, even optimize specific apps before it overheats. Truly smart thermal management.
That sounds game-changing. Predictive cooling, not just reactive.
Mm-hmm. And one more area, maybe a bit further out, is using the display itself more actively. Glass panel heat transfer. Utilizing the large surface area of the screen layers as part of the pathway to dissipate heat, making literally every part of the phone contribute to staying cool.
Turning the screen into a radiator, too?
Oh,
What?
yeah.
It's all about finding new pathways and efficiencies. Because at the end of the day, better cooling isn't just about comfort. It's about unlocking and, crucially, sustaining the peak performance these amazing chips are capable of. These innovations are key for what comes next. And stepping back just a little, thinking about all these complex, mostly invisible cooling systems, it makes you wonder, doesn't it? How might our whole idea of smartphone performance shift? Maybe it becomes less about just peak benchmark scores, raw speed, and more about the ability to sustain good performance over time without overheating. Efficiency and endurance becoming just as important as raw power. It certainly raises an interesting question for the future.
Absolutely. Well, now you know why your phone gets hot, and more importantly, the incredible engineering Apple uses to try and keep the iPhone 17 cool. It's clearly not just about the chips themselves, but this whole ecosystem, right? The chips, the layout, the special materials, the software all have to work together perfectly. Thanks for joining us on this deep dive. Subscribe to FAB Plus, and let's keep exploring tech one layer at a time.